There are multiple companies who use time series databases. So Scylla Summit is a place where I can meet other engineers, other like-minded people, and bounce out some ideas on how to do things, and maybe even figure out kind of a proof of concept design as when you are sitting in the conference, and maybe even do some kind of a coding exercise. But first and foremost, thanks a lot for taking the time and attending the talk here. And thanks a lot, Greg, for the great introduction. So the topic is Grab and Scylla driving SEA forward. SEA, it's abbreviation for Southeast Asia. It's not the airport code for Seattle, even though that's where I come from, but it is Southeast Asia. Just a brief bio about myself. I'm a lead software engineer at Grab. Pretty much working on a real-time team, real-time streaming platform, real-time data platform infrastructure. That's me and my team together working on it. Prior to Grab, was part of Uber, worked on the data infrastructure team at Uber. We built a queuing system from scratch. It was an awesome experience there as well. Prior to that, I was actually doing file systems work, distributed file systems, completely different world than the current world that I am in. And then before that, I did my master's in UEA, University of Virginia. This is my email contact. If people would like to reach out to me, definitely feel free. Now, the agenda of the talk. First and foremost, a brief overview of what Grab is before I go into the details. And then the motivation of why we chose Scylla, why I am actually here today. And then the other thing is the ScyllaDB use case at Grab, what we use Scylla for, and how it actually impacts people's lives. So that's also nice. And then finally, some conclusions, some thoughts on the current experience with Scylla, and then some Q&A if people have questions. And FYI, this talk will be short, but it is intended to be short. So just a brief background about Grab. Greg gave a very nice introduction. Grab, people know it as Uber of Southeast Asia, but it is much more than that. If you see the slide here, I say it is one of the most frequently used mobile platform. I don't say it as ride sharing because it is now much more than ride sharing. It of course started as ride sharing. Now there are multiple different things that Grab does. Transport is of course one of the core components of it. That's the one which started on. Now we do food, we do payments, which is a huge deal by itself. Shopping, package delivery, lots of new verticals that keep popping up. That's why I call it a mobile platform. The eventual goal is to get to a place where technically in Southeast Asia, if you are in one of the countries in Southeast Asia, you can use the Grab app. Go to a, let's say, take a Grab ride, get on a car, go to a grocery store, buy milk, buy groceries, use the Grab app to pay, come back, go get a coffee using the Grab app, get home on a Grab car. So pretty much the entire ecosystem, Grab ecosystem as part of Southeast Asian life. That's the eventual goal of Grab. So now this is a very brief introduction about Grab for people who don't know. Next is the motivation of why we actually chose Scylla. So why ScyllaDB? Actually, one mistake that I did here, my animation skills suck. You can see the Apache Kafka should have come once I clicked this. Like it should have been here, but then it just showed up at the end, so excuse me for that. But anyway, the thing is, Grab technology, pretty much like most of the other current trending companies, it involves tons of microservices. We are mostly based everything in Golang, so most of the tech stack is Golang. And then we use Apache Kafka for streaming. So once we have microservices, I can give a streaming 101 completely as well. I don't want to get into that. So we used to be a monolith, and then we converted to microservices. There was databases, and then there was more load on database, and then eventually we wanted to scale. We wanted to do loose coupling. We want to scale asynchronously. That is when we introduced Kafka. Kafka for streaming, and pretty much my team works on Kafka, all the things around Kafka, streaming platform, stream analytics and stuff. So this is an overview of GrabTech. This again, next is, even then, why we chose Scylla. This explains why we chose Kafka. So now we gave streams to engineers. So people were really happy, they use streams to build their stuff, but then engineers are never satisfied. So once you give them streams, they want to do a bunch of things. I want to do stream processing. I want to do transforms. I want to do aggregates. I want to do joins. I want to do all those things. Like yesterday, you must have seen the Confluent speaker speak about KSQL, streams, all those things. They are building all those awesome products just because people want it. People need those things. So similarly here, all the engineers, they wanted stream processing, transforms, aggregates, joins, everything. So now, when people wanted those, it required a state store, or you can call it a metadata store, which has the following characteristics. Like you have multiple different streams, you want to join them together, very high throughput. So it should have the ability to handle high throughput. Lots and lots of bursts, because Grab or Uber or any ride-sharing company, or in this industry, this particular industry, if you see, there is a well-defined peak hour, similar to, let's say, e-commerce. E-commerce guys have peak hours during Thanksgiving, New Year's, whenever there is a sale. Similarly for us, peak hour is pretty much every evening around 5:30 when people want to get out of the office, go home, and during the morning as well, and also during the weekends. So this is our peak. So we should be able to scale for the peak immediately. If you say you can scale in like 15 minutes, 20 minutes, it's great, but it won't work for us because it just scales immediately for us. And then very low latencies, because we are a real-time team, and most of my team's customers are other engineers who are building their products and stuff, as you will see soon, who want the data in near real-time, like sub-milliseconds, or extremely fast. And also low operational overhead. I already have a baby at home. I don't want to baby another cluster, another at work, so I want as much low overhead as possible, and also cost efficient. So we pretty much want everything. We didn't want to compromise on any of these things. That is when we ran into Scylla. And it has been working well so far. Really, really nice experience. I will talk about it later. But yeah, I can give a huge slide again on how we compare Scylla with other DBs and stuff, but you get the idea. Scylla, eventually we chose Scylla for doing all of our stuff. So that's the motivation. That's how we landed on Scylla. That's how it all started with Scylla. Now ScyllaDB usage, what it is being used for. I kind of already gave an idea on stream aggregation, stream statistics, so I will probably repeat the same thing, but with at least some concrete use case of it. Number of use cases, stream aggregation and stream statistics is one of the major thing, and one of our major customers are fraud detection team, who are engineers who have to keep up with the scammers on our Grab platform. The scammers are very intelligent as well, so they are like hackers, right? So they come up with very innovative ways to tackle our platform, and so they are one of our predominant use cases. And the other thing is, once we rolled out preliminary stream aggregation, stream stuff, people want more and more statistics on it. They start seeing the numbers that we provide, and they really like it, and they want to keep building on top of it. This slide is just gives you a background on fraud detection and how it is extremely critical for Grab platform. These are a couple of articles which were published on how scammers affect this particular industry, not just Grab, every other company. This is particularly in Southeast Asia, but it is true everywhere, I would say. And there is also a Grab log. I forgot to link it here, but I can link it later. One of the user trust engineers in our engineering org, he wrote a nice blog on what it means to be affected by a scammer. When we think of fraud and scamming a platform, we generally think of it just contributing to the business, right? Like, so if somebody does a scam on our product, we lose money. It's not just that. Since this platform is being used by other people to earn money, so if you allow a scammer to, let's say, book a false ride or impersonate a driver or a passenger or something, then it means that particular driver is losing a job. If he loses a job, then he or she probably loses an incentive, a bonus, or some kind of a money. They would have some aggregate count, like if you get to 10 rides, you will get $50 more. So that one ride could have gone to that driver and they could lose substantial money. So not just the business, it impacts the customers as well. So that is one of the things, as an engineer, that is one of the things I felt really good about all these things. We as engineers like to build really cool products, really cool solutions, but having those solutions being used in a real life use case, which is actually impacting people, it is really awesome. And thanks to Scylla as well, since it is playing an important part on that particular thing. So basically how that works is we kind of use Kafka streams to do real-time flagging of rights. So this needs to happen in real time. So when let's say, if I'm a scammer and I want to impersonate something and I want to book it, those guys have their own algorithms. I don't want to get into the algorithm on what they do, but they will run their own algorithms. The trust and safety engineering team, they will run their algorithm and they want to flag that right immediately. So it should be done immediately, not after the fact, not later on. So in order to do these, they will combine multiple streams. Why multiple streams? Because as a platform, if you think of Grab, it has multiple different entities. So there is a passenger entity, there is a driver entity, there is, let's say if you take care of food, there is a vendor entity, there is a merchant entity, there is a payment entity. So there are lots and lots of entities. And this is a microservices world, so each is probably being hosted by multiple different services. So each will be publishing to different Kafka streams. And these guys, the scammers, generally they kind of coordinate. They just won't impersonate one entity. They will try to combine with multiple different entities and work together. So in order to properly calculate all the fraud analysis, fraud detection and stuff, they want to combine multiple different things. You can think of it like, let's say if people have seen Iron Man movie, where the Iron Man just stands near the virtual reality screen and then he will combine like multiple different things put together and say, okay, I got the solution. It's pretty much like that. So the trust and safety team will come to us and say, okay, I want to combine this stream, and the other stream together. This is the key, and I want to get the result. And we need to be able to provide it in near real time. So if we even do it in like, let's say 2 seconds, 5 seconds and stuff, it doesn't matter. The fraud is already committed. So that is one of the major use cases. I feel that's an interesting use case that we use Scylla for. Next one, statistics. Who doesn't love statistics? Everybody likes statistics, right? So once we rolled out these things, people want more and more statistics. I know like Alec contacted me, synced me with Brian on this. You will soon see why. But the ScyllaDB usage, one thing that we use is for stream statistics. Once you have streams, people will want to say counts of ... So they want to say count of rides in the past month, past year, etc., etc. And they could also want some raw stats for some key, for maybe some debugging purposes like tech support or some other thing. Eventually, like even business users might want to see some data, right? They want to see some statistics on, okay, how we are doing in, let's say, this particular city. In Singapore, what's our ride count? Are we doing well? Is it matching up to our own expectations? Should we do more promotions or should we do some other things differently and stuff like that? So all these things are some of the requirements that people come to us with, and some of the things that we constantly keep using Scylla for. Initially, we just said, okay, we will build our own kind of stat stuff, and then it requires a fast store for raw stats. We just rolled out counts, and people were interested in counts, and counts we can build easily on top of Scylla. But now people want more and more stuff on top of it. Basically, they want to do some kind of time series on top of it, like P95, P99, and other things. I'm saying hello to KairosDB because we are right now in the process of doing a proof of concept with KairosDB to make sure it can satisfy and handle the requirements that we have. So that is one of the major use cases we have. And to be honest, these are the numbers. It might not be as impressive as you have seen in the field, but it is still a stepping stone into the company. It is a small portion, but like I said, it plays a major role in some of the very critical pieces of the company. So we right now just have one 15-node cluster. We are running 2.2, and we are running on AWS EC2 instances. Right now it's just single DC. We may go to multi-DC in the future, but right now it's just single DC. Overall, approximately, we just have 15 terabytes of data across all nodes, but we keep seeing interest on ScyllaDB every single day. It just keeps increasing. Even right now, before the talk, some other team was pinging our team channel, Slack channel, saying, hey, can you guys support this and this? So it's pretty much it's increasing every single day. This is just a raw number I have from I think 2-3 weeks ago. This is our peak. Right now we do like 70K. Actually, this was like 3 weeks ago. Now it's I think around 100. That dip, I have no idea. I need to investigate why there is a huge dip there. But this is just a pure operations per second. Again, to conclude, overall, we have had a great experience so far with ScyllaDB. It's been very cost-effective and very responsive team. So that I have to definitely shout out to the Scylla team. I have posted multiple questions in the Scylla Slack users, and they have responded every single time immediately, irrespective of what time or day or anything it is. And at least so far, it is as good as advertised. We have seen it work very well. It is growing within the company. Of course, with all the positives, there are some hiccups as well. We have encountered some hiccups. No tool repair, even though compared to other DBs, compaction is way, way better. It doesn't bring the entire cluster down or anything, but we notice an interesting phenomenon, like the writes and read timeouts every single time when the run finishes. But unfortunately, we couldn't gather all the logs. We run with the default log level of info, and we couldn't find any logs. We just have the graphs, and that is one probably a request, or maybe some maybe a small feature request where it says better error logging. So if let's say if there is some kind of a read timeout or write timeout, if those can be logged by default in the error level, it will be useful at least for debugging. For right now, we don't know why that happens, and generally when it happens in a very weird time at like 2 a.m. or 1 a.m. Seattle time, so it is very hard for us to turn on debug logs, and I try to repro it outside of the main cluster. It doesn't repro at all, so I'm pretty sure it has something to do with the partition size. I need to check there. And the other thing is, of course, I understand nodes joining, it needs to stream all the data. It needs to make sure all the ranges are in sync. So it will take a long time depending on the amount of data. But still, maybe this kind of follows up with the morning talk on consensus. I forget the name, Duante, or somebody gave a talk about the consensus stuff. He mentioned node membership as part of the future plan. Maybe this is what he mentioned, like concurrent node membership. But right now, This is also one thing, like if we want to keep adding nodes, it will take some time for us to add, which is okay, because we kind of expect we have alerts on loads and other things, so we will be cautious, but still it will be useful if that can be a bit faster. So that's it